Hello and welcome. This is lecture number 4 on trigonometric functions. So far we have seen the following functions in this chapter. We have seen that cos of x plus minus y is equal to cos x cos y minus plus sin x sin y. We have seen that sine of x plus minus y is equal to sin x cos y plus minus cos x sin y. Then we have seen that tan of x plus minus y is equal to tan of x plus minus tan of y divided by 1 minus plus tan of x tan of y. Then we have seen that cot of x plus minus y is equal to cot x cot y minus plus 1 divided by cot of x plus minus cot of y. Then we have seen that cos of 2x is equal to cos square x minus sin square x, which is also equal to 2 cos square x minus 1, and which is also equal to 1 minus 2 sin square x. And this is also equal to 1 minus tan square x divided by 1 plus tan square x. Then we have seen that sine of 2x is equal to 2 sin x cos x, and this is also equal to 2 tan x divided by 1 plus tan square x. And we have seen that tan of 2x is equal to 2 tan x divided by 1 minus tan square x. Then we have seen that sine of 3x is equal to 3 sin x minus 4 sin cube x, and cos of 3x is equal to 4 cos cube x minus 3 cos x, and tan of 3x is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. From those functions, we have obtained that cos of pi by 2 minus x is equal to sin x, sin of pi by 2 minus x is equal to cos x, cos of pi by 2 plus x is equal to minus sin x, sin of pi by 2 plus x is equal to cos x, and cos of pi minus x is equal to minus cos x, and sin of pi minus x is equal to sin of x. We have also seen that the cos of x plus cos of y is equal to 2 cos x plus y by 2 and times cos of x minus y by 2. We have also seen that cos of x minus cos y is equal to minus 2 sin x plus y by 2 sin x minus y by 2, and we have seen that sin of x plus sin of y is equal to 2 sin x plus y by 2 cos x minus y by 2. And lastly, we have seen that sin of x minus sin of y is equal to 2 cos x plus y by 2 sin x minus y by 2. The last topic of this chapter is trigonometric equations. Trigonometric equations are equations involving trigonometric functions of a variable. The solution of trigonometric equations for which x is between 0 and 2 pi is called principal solution, and the solution involving integer n, which represent all the solution of trigonometric equations, is called general solution. Before moving ahead, we will take an example first. Sin x is equal to half is a trigonometric equation involving the angle x and its trigonometric function sine. We will find the principal solution of this equation. We already know that sine of pi by 6 is equal to 1 by 2. So the first principal solution of this equation is x is equal to pi by 6. We also know that sine of pi minus x is equal to sine of x. This means that sine of pi minus pi by 6 is equal to sine of pi by 6. But pi minus pi by 6 is 5 pi by 6. This means that sine of 5 pi by 6 is equal to sine of pi by 6, and this is also equal to 1 by 2. Therefore, the second principal solution is x is equal to 5 pi by 6. So, therefore, the principal solutions are pi by 6 and 5 pi by 6. We have seen in the previous example that to solve a trigonometric equation, we need to compare a trigonometric function of a variable to a trigonometric function of a constant. For comparison, we need some rules, some guidelines, and these rules or guidelines are called theorems. So the first theorem that we will use for solving the trigonometric equations is For any real values of x and y, if sine x is equal to sine y, this implies that x is equal to n pi plus minus 1 to the power n y, where n is any integer. Now we will apply this theorem in the previous example. In this previous example, was given that sine x is equal to half and this is equal to sine of pi by 6. From this theorem, we can see that x is equal to n pi plus minus 1 to the power n into pi by 6, where n is any integer. Now for n equals to 0, x comes pi by 6, and when n is equal to 1, x becomes 5 pi by 6. Therefore, the principal solutions of this equation are pi by 6 and 5 pi by 6. The proof of theorem 1 goes as follows. If sine of x is equal to sine of y, this means that sine of x minus sine of y is equal to 0. Now we have seen the trigonometric function that sine of x minus sine of y is equal to 2 cos x plus y by 2 sine x minus y by 2. This means that sine of x minus sine of y equal to 0 implies that 2 cos x plus y by 2 times sine x minus y by 2 is equal to 0. This implies that either this cos function has to be 0 or this sine function has to be 0. Taking first the cos function to be 0 and proceeding, we get cos of x plus y by 2 equals to 0. And this means that x plus y by 2 is an odd multiple of pi by 2, that is 2n plus 1 pi by 2. This means that x plus y is equal to 2n plus 1 pi, and this means that x is equal to 2n plus 1 pi minus y. Generalizing it, we get x is equal to 2n plus 1 pi plus minus 1 to the power 2n plus 1 y. Since 2n plus 1 is an odd number, therefore minus 1 to the power 2n plus 1 will always be equal to minus 1. From sine x minus y by 2 equal to 0, we proceed as follows. Sine of x minus y by 2 equal to 0 implies that x minus y by 2 is an integer multiple of pi. This means that x minus y is equal to 2n pi, and this means that x is equal to 2n pi plus x. This means that x is equal to 2n pi plus minus 1 to the power 2ny. Since 2n is always even, minus 1 to the power 2n will always be plus 1. Therefore, for sine x to be equal to sine y, either x has to be 2n plus 1 pi plus minus 1 to the power 2n plus 1 y, or x has to be 2n pi plus minus 1 to the power 2n y. We can see that in this equation minus 1 is raised to the power an odd integer, and in this equation minus 1 is raised to the power an even integer. Similarly, the coefficient of pi here is an odd number and coefficient of pi here is an even number. Therefore, combining these two, we get all the integers. Combining even and odd, we get all the integers. Therefore, combining these two, we get x is equal to n pi plus minus 1 to the power n times y for all n in integer values. The second theorem for solving the trigonometric equation is for any real numbers x and y, cos x equal to cos y implies that x is equal to n pi plus minus y, where n is any integer. Again, we will take an example. If cos of x is equal to cos of pi by 6, this means that x is equal to n pi plus minus pi by 6 from this theorem, where n is any integer. For n is equal to 0, x is equal to plus minus pi by 6, and for n is equal to 1, x is equal to pi plus minus pi by 6. Therefore, the principal solution of this equation is x is equal to 5 pi by 6 or 7 pi by 6. The proof of theorem 2 goes as follows. If cos of x is equal to cos of y, this means that cos of x minus cos of y is equal to 0. And from the trigonometric functions derived earlier, we can conclude that minus 2 sine x plus y by 2 times sine x minus y by 2 is also equal to 0. This means that either sine x plus y by 2 has to be 0 or sine x minus y by 2 has to be 0. From sine of x plus y by 2 equal to 0, we proceed as follows. Sine of x plus y by 2 equal to 0 means that x plus y by 2 has to be an integer multiple of pi. This means that x plus y is equal to 2n pi, and this means that x is equal to 2n pi minus y. From sine of x minus y by 2 equal to 0, we proceed as follows. Sine of x minus y by 2 equal to 0 implies that x minus y by 2 has to be an integer multiple of pi. This means that x minus y is equal to 2n pi, and this means that x is equal to 2n pi plus y. Combining these two, we can see that y can have both the sign minus or plus. Therefore, we can combine to get this x is equal to 2n pi plus minus y. The third and the last theorem goes as follows. If x and y are not multiples of pi by 2 and tan x is equal to tan y, this means that x is equal to n pi plus y, where n is any integer. For example, if tan x is equal to tan pi by 4, this means that x is equal to n pi plus pi by 4, where n is an integer. For n equals to 0, we get x is equal to pi by 4, and for n is equal to 1, we get x is equal to pi plus pi by 4 equal to 5 pi by 4. Therefore, the principal solution of this equation is x is equal to pi by 4, 5 pi by 4. The proof of this theorem goes as follows. If tan x is equal to tan y, this means that tan x minus tan y is equal to 0. This means that sin x by cos x minus sin y by cos y is equal to 0. Taking the LCM, we get sin of x cos of y minus cos of x sin of y divided by cos x cos y is equal to 0. This means that numerator has to be 0. But from the trigonometric function seen earlier, we see that sin of x cos of y minus cos of x sin of y, this is equal to sin of x minus y. Therefore, sin of x minus y has to be 0 if tan x is equal to tan of y. This means that x minus y is an integer multiple of pi, and this means that x is equal to n pi plus y. Now let us take few examples. In this example, we will find the solution of sin 2x minus cos x equal to 0. Sin 2x minus cos x equal to 0 implies that 2 sin x cos x minus cos of x is equal to 0, since sin of 2x is equal to 2 sin x cos x. Taking cos x common, we get cos of x into 2 sin x minus 1 equal to 0. This means that either cos x is equal to 0 or 2 sin x minus 1 is equal to 0. Cos x equal to 0 implies that x has to be an odd multiple of pi by 2. That means x equal to 2n plus 1 pi by 2. 2 sin x minus half equal to 0 implies that sine of x is equal to half. This means that sine of x is equal to sine of pi by 6, since sine of pi by 6 is equal to half. And from theorem 1, we get x is equal to n pi plus minus 1 to the power n times pi by 6. Therefore, x has to be either odd multiple of pi by 2, or it has to be n pi plus minus 1 to the power n times pi by 6 for this equation to be equal to 0. In this example, we are given that 2 cos theta cos pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 is equal to 0. We are required to find the value of theta. Using the function cos x plus cos y equal to 2 cos x plus y by 2 cos x minus y by 2, and applying it on the last two terms, we get 2 cos theta cos pi by 13 plus 2 cos 4 pi by 13 cos pi by 13 equal to 0. Taking 2 cos pi by 13 common, we get 2 cos pi by 13 times cos of theta plus cos of 4 pi by 13 equals to 0. Since we know that cos of pi by 13 can't be 0, this means that this term under the bracket has to be 0. This means that cos of theta plus cos of 4 pi by 13 has to be 0. This means that cos of theta has to be minus cos of 4 pi by 13. And we know that cos of pi minus x is equal to minus cos of x. This means that cos of theta is equal to cos of pi minus 4 pi by 13, and this is equal to cos of 9 pi by 13. Applying the theorem 2, we get theta is equal to n pi plus minus 9 pi by 13 for n belonging to integers. So let us summarize this lecture. We have seen that the trigonometric equations are equations involving trigonometric functions of a variable. Trigonometric equations have principal solution and general solutions, and theorems are needed to compare trigonometric functions of a variable to a constant trigonometric function.